Hello, everybody, and welcome to our first segment of Facebook Live at Lunchtime. I'm John Rogers. I'm the Environmental Control Supervisor for the Columbia Field Office. Out of the field office here in Columbia, we do inspections of underground storage tank facilities and hazardous waste sites and solid waste sites. Today we're at one of our more unique solid waste permitted sites. We're at Mac Farms in Taylor County today. Mac Farms is a fun place to come to because it's a large-scale ag operation. It's a working farm. We've got several poultry houses in the background here. But the reason we're here today is in 2015, Mac Farms received a permit by rule from the cabinet to take food processing waste and operate an anaerobic digestion unit. So you might say, and we performed compliance inspections since that day in 2015 out here on a routine basis. Now, you might ask, what is anaerobic digestion? And it's a natural process that happens when microorganisms break down organic material and creates methane gas. Some people call it biogas. So now how it typically works on a farm like this is you introduce manure, food processing waste, beverage waste on a consistent basis. It's important that your waste is consistent, and the waste is heated up, and that bacteria essentially breaks down the organic material and creates that gas. And then the gas is captured through a process, and then sometimes it's even sent to a motor to create electrical power. So that's a possibility with these sites too. Now here at Mac Farms, what they're doing is they're bringing in that food processing and beverage waste, and they're adding non-chlorinated water, and they're creating a slurry. And it's unloaded here in the background, and that slurry goes into the primary digestion unit, and then from there it is processed and pumped over to the secondary unit that is off in our background here, and it has a bladder that captures the gas on there. Now, they also have a digestate material that they create. They store what they can't use in the unit, and some of that is land applied to the fields to provide good soil health in the background. So the idea here is how can we as a farm best use our resources and be good stewards of the land. Today with me I have the owner of Mac Farms, John Mclean, and John McLean's going to explain a little bit how he got started in this endeavor, and some of the challenges he's had and some of the visions he had going in, and how things have changed and how he's overcome some of those challenges. So John, thanks for having us here today, and I'll turn it over to you.
All right, thanks John. So my name's John McLean, and I'm the owner of Mac Farms. So anaerobic digestion has been a passion of my life for the last 10 years. So in 2003, we built poultry houses, and one of the first things that I noticed is that they are energy monsters. They use a tremendous amount of energy. So what we decided to do is try to take material from the chicken litter from those barns and make methane gas through anaerobic digestion. So we started that process about 10 years ago. As we started doing that, we realized that it wasn't financially feasible on the scale that we are currently at. So we decided to introduce food waste and, like John said, beverage waste and waste streams, and actually some animal feed waste. So we got the permit and we started moving forward on that. So it was really tough in the beginning. The biological side of the anaerobic digestion process is very tricky, balancing your different feedstocks and making sure she stays healthy. So 4 years ago, we started dealing with also some stillage from the bourbon industry, and that posed its own challenges, but we worked those kinks out and feel very strong about dealing with that product at this point. One of the things that's the most beneficial from this process is that we're receiving feedstocks that are often 3.5 to 4.5 in pH, and when it comes out of the backside of the digester and is land applied, it's above 7. And so our wastewater permit, requires us to take the BOD and the total solids and the pH on that product that is land applied. So, and it's always in the mid 7s, 7.4 to 7.5, somewhere in that range. So the other major benefit of the anaerobic digestion process is, for example, whole stillage right off of a bourbon still is 160,000 mgl BOD. So what we apply, once it goes through the digester to the fields, we've dropped that down to anywhere from 1,000 mgl to about 7,500 mgl. Sometimes in the winter, when it gets really cold, that process slows down and we might get a 9 or 10,000. But we're still dropping that. Keep in mind, we're dropping that BOD down from 160,000 milligrams per liter of biological oxygen demand. So you can also do that within a municipality. That's possible through an oxidation ditch where you're aerating that product, but there's a lot of energy that goes into that. Through this process, it is carbon neutral. We use energy, but we have the potential to create more energy than we use. So when we're dropping those BODs down in these materials, the most exciting part to me is that we're doing it with very little energy consumption. Right. The product that we have on the backside, the digestate, is a high nitrogen product because the anaerobic digestion is anaerobic lack of oxygen. It's in an enclosed system, so that nitrogen cannot escape. So it has a lot of nitrogen in it. And what we've noticed is soybeans are very delicate with this material, so you have to keep your amounts that you apply to the soybeans in a very low amount. The corn is much more beneficial from using the digestate. It uses up a lot of nutrients and it uses a lot of nitrogen. So we're seeing a huge advantage by growing corn with this product.
John, you talked a lot about bourbon waste, and we are here in Kentucky, the home of the Bourbon Trail. We've got bourbon tourism, and we're just making a ton of bourbon right now, and that creates a lot of waste through that process. And that's a waste that typically in Kentucky was fed to cows. And now we're making more bourbon than we've got the cows to feed it to. And so that creates a problem, is what do we do with that waste? And that's a waste that's often mismanaged, and we just don't have a lot of good avenues for disposal or reuse. So could you talk a little bit about your relationship with the bourbon industry and how you got involved with them and how that relationship is working so far? So,
sure. I think our relationship has been positive so far. We've dealt with several distilleries. Sometimes it is a challenge for us to be cost competitive with traditional means of dealing with whole stillage, because this is a 7-figure investment and it's not a large scale digester. So we are looking in to potentially build larger scale digesters to deal with that material, place it logistically in places that keep costs down and it can be more cost competitive. The biggest advantage, and I'm going to lean back again to, and this is when we talk about biological oxygen demand, your BOD in these materials, that is the biggest advantage to anaerobic digestion, is we can drop that BOD down in stillage, and stillage runs about 140,000 mgl per liter of BOD, all the way up to 170, depending on the mash bill. So we're dropping that down to well under 10,000. We've even had some success getting all the way down to 250 mgl. And so once we get to that point, it's really easy to dewater that product. Then you have a solid product, and then that water. Let's say you're in the edge of of an urban area. Then you can take that filtrate that you've dropped the BOD out of with energy efficiency, and you can get a permit with potentially a municipality or something, and let them take it on down to the discharge rates that it needs to be at. The advantage to that is to us and to the municipality would be that we're sending them diluted water, clean water that can dilute their system, which really helps. And then also we can send it at a very consistent rate. So 100 gallons a minute or 125 or 200 or whatever that might be. So that would be the biggest advantage of anaerobic digestion when we're talking about the bourbon industry.
Yeah.
Now that being said, there are some really big biological hurdles that we must, that has to be dealt with on a daily basis when you are digesting whole stillage or wet cake or thin stillage or syrup or whatever material that you happen to be, and we've dealt with all of them. So we can deal with it. We are very proud that we can deal with that. I also have a full-time biologist with 25 years experience in the wastewater treatment business that takes lab samples on a daily basis that works here. And so we are monitoring the health of digester on a daily basis.
Mm-hmm. One of the things that is really exciting too, but it has some challenges in today's world, is the ability to create power, electrical power here, and use that power, and even the possibility of somewhere down the road of in some location putting that back into the power grid. But there's a lot of challenges to getting set up to go full force with that, and could you talk about that a little bit?
Sure. So we do have a power purchase agreement with East Kentucky Power. They're great to deal with. They have a strong renewable sector. They have some solar, and they also sell electricity made from landfill gas. They are a pretty strong component of renewables. Unfortunately, the price per kilowatt that we sell at right now is really about a break-even point for us. So we've got a $500,000 generator that we choose not to run. We just flare our gas currently to make sure that methane is not escaping into the atmosphere. So the biggest challenge is not so much getting your power purchase agreement as in this country right now, it's just electricity's cheap. And I can appreciate that. We use electricity here. And so it's not something that I'm against. I'm not asking for high electrical cost. But when looking at putting that gas through a combustible engine, which is not very efficient, to sell electricity, in my view, is potentially not the best way to go, unless you have a very specific need for that electricity. If you have a very specific need for that electricity, then it changes. If you can use all the electricity that you produce, or you have someone adjacent to you that can use all that electricity, it's very positive. The other option of that is you can put a gas upgrading system in, which will allow you to clean that gas to pipeline grade. You can put 100% of it back into the pipeline, 100% of the methane. It scrubs the hydrogen sulfide, the H2S, and it scrubs the carbon monoxide out. And you can also capture that and use it in different markets, and actually has a value. Mm-hmm. You can sell that in different markets, so you can capture the CO2 as well.
Yeah. And another thing, you were talking earlier today about soil health, and can you touch a little bit about the soil health improvement of your farm for the land application of the Digestate? So,
Okay, yeah, sure. And I know we're getting tight on time here. So the biological activity that's happening in the digestate, the backside of the product, is very readily available to crop uptake. And so not only does it help increase organic value in your soil, but every bit of that is available for the crop.
yeah. So what we see here, we have a good partnership with Mac Farms through our office in Columbia and the cabinet. We do routine inspections out here. Our job is to provide technical assistance and keep the site into compliance. John's job is to stay in compliance, and we've had a good partnership since he was permitted in 2015, and we are sure that will continue. So John, we'd like to thank you for having us out here today, and thank you for your input, and we look forward to working with you in the future.
Sure, thank you.